I'm Nick, and this is a pile of hardware that I'm using to build our new, let's call it our working server. Essentially, we have a storage server that we use for working daily, rather than all of our archive storage that we've got for everything else. It's usually SSD, it's high-speed networking, and it does a few cool little things that regular storage servers may or may not do. So what I want to do is show you all of the hardware, how I put it together, how it's configured, and then we're going to test it to show you guys what this thing will be capable of. Also, shout out to Samsung for sending quite literally a mountain of 4 terabyte drives for this. Absolutely insane. Yeah, this isn't even all the drives that they sent us, because they sent us more for another storage project, which we'll be doing soon, which will involve our archive storage, which is completely insane. But this one is really cool because you may have seen on the channel a few weeks ago me talking about the 3D printer that I bought, me really getting into 3D printing, and seeing this case in that video where I designed it, because this is not an off-the-shelf 2U rack mount enclosure. This is a case that I have designed. Well, I've designed the front panel from scratch, and this is something. Anyway, let's put it together and I'll explain how all of this works, because yeah, it's quirky, kind of like me. I don't think quirky's cool anymore, is it?
You're so quirky.
Yeah, I don't think I'm cool anymore. This is just how I am. This is a motherboard that we covered a few weeks ago. This has a CPU integrated on the board itself. It's got the Ryzen Pro 8845HS. It's a mobile processor with 8 cores and 16 threads. And you guys had more questions about it, and I've had a bit more time to tinker with it. As well as that, for memory, I've decided to go with 64 gigs of Corsair Vengeance DDR5. I have this laying around from another system, and I was like, oh, we'll just put that in, why not? I didn't populate the M.2 slot on the back of the board, basically because it would mean that if I was to change the drive, I'd have to take the whole board out, and the RAM's okay, because I don't really change that very often. There's a single 256 gig M.2 drive for the boot drive on the board, and that's basically it. If you're interested in knowing a little bit more about this board in particular, there's a video down below in the description that goes into basically everything with this board and its entire feature set. But to summarize that for you guys, it's got dual 10 gigabit Ethernet and USB 4, which is a must-have for a server. Well, at least for me. As for storage, we've got a couple interesting things going on here. Primary storage is handled by this enclosure here. This is an 8-bay Intel enclosure. They'll support 8 2.5-inch SATA or SAS drives. And as I've already mentioned, I've populated these with a series of Samsung 870 EVO 4 terabyte drives, giving me a total primary storage pool of 32 terabytes. Which is, yeah, it's quite a lot. And when you see how we work, it's just on the edge of being the right amount. This isn't all of our storage. Even 100 terabytes worth of storage is rookie numbers. We need way more than that. We do things a little bit differently here at Gear Seekers. Everything that you're seeing that comes from my face down the lens is shot in Blackmagic RAW at 6K. All of our cameras shoot Blackmagic RAW 6K. Doesn't matter who makes them, we shoot in the same codec. So we need lots of working storage day to day. Why do we shoot in 6K RAW for YouTube videos? Why the f not? As I've already mentioned, the front of this case is designed by me and 3D printed by me. If you really want the STLs, I can make them available, but I mentioned all of this already when I did the video showing this initially, but it's got 3 80mm Noctua industrial fans at the front. They're very quiet, they're only 1200 RPM. There's a little combined power light with a power button here that I harvested from another case that I had. And this essentially is, well, at least for me, the perfect balance of airflow with those fans, as well as storage capacity. Now, the next thing is you're probably wondering how all of the storage is going to be connected up to the Miniroute N7. This board right here has a little trick up its sleeve, because the Miniroute N7 has dual 8643 mini SAS HD connectors. This has 2 independent controllers, and to be honest, it only gives you access to 4 out of the 6 drives that would technically be available with twin controllers. So you can only use 8 drives, not 12. I hope that makes sense to you guys, but for this configuration, it is absolutely perfect for the use case that I want to use it for. Whereas our Intel enclosure has twin SFF 8087 mini SAS connectors. Though each end of the cable is technically different, and you may not know this, but mini SAS cables that go from 8643 to 8087 are widely available. And this is a nice one because it's only 50 centimeters long. Some of them are just too long to fit inside enclosures, and you have to kind of bunch them up. But this one I can just do a simple loop, and it should be good to go. This is one of the most satisfying sounds in all of computing. Are you ready? Luckily for you, you get to hear it again. If you're serious about network storage and you've got the need for speed, you're going to need some SSD cache. Now, these are not the fastest drives in the world by any means. They do have capacity though. These are both PCIe Gen 3 drives, but 3.5 gig a second. Think about the limitations of the networking in here. We've got dual 10 gig. We're not even gonna be able to saturate the cache anyway. So it doesn't really matter. Although we do have USB 4, for the workflow that I'm using this for, I don't need anything faster than 20 gigabit. When it comes to use cases and realistic uses for things that you're actually going to use, not just a YouTube video about the fastest possible thing in the world, these are things you should be considering. This little storage card is a bit of an interesting one. I picked this up on Amazon for, I don't know, maybe $15 Australian, and it has 4 M.2 slots on it. You will need a motherboard that has bifurcation to use something like this. And because this by 16 slot is only technically a by 8 slot and it does support bifurcation, I'm only using 2 drives for SSD cache here. If this had a full by 16 slot, then I would definitely use all 4 drives. But again, 2 is gonna do. To be honest, the other storage server that I'm using for my daily work, it's completely M.2 NVMe SSD, but there's no caching. So this potentially will be faster than that setup because of the cache. Just going back to this card, the reason why I chose it is because of its form factor. You can see here that it's got 4 slots, as I've already shown, but it's got 2 on the front, 2 on the back. But typically, when you buy these cheap storage cards off somewhere like Amazon, there'll be a full height card. This is a low profile card, so it will fit in a 2U server without any problems whatsoever. Let's say you were using an MATX board in this case, which is what it's technically designed for. You could just fill that up with drives, and you could have 4 drives instead. That's actually why I bought this card initially, because I was going to use a different motherboard, and then this one came and I was like, hey, this one's actually perfect. And the other board I was thinking of using, I can't get another one. It's got dual 25 gig, but yeah, that's a story for another day. Let's talk a little bit about the configuration of this new storage server. Quite obviously, we're using TrueNAS. It is the best tool for the job. It is the only solution you should be looking at if you're serious about storage on your network. There are alternatives out there, but this is the product you should be using. Full stop, end of story. You can see here, we've got the AMD Ryzen 7 Pro 8845HS, 8 cores, 16 threads. The hottest core right now is 25 degrees, which is absolutely nothing. Let's hope it stays that way. We've got our 64 gigs of RAM. We've got our single storage pool here, which is 8 drives wide with a total usable capacity of 24.37 TB. The other parameters of this pool is there's 2 cache drives here. We've got 2 network interfaces connected, one of them being one of the 10 gigabit Ethernet adapters, and Thunderbolt, which is a whole rabbit hole for TrueNAS, which I'm going to be writing a script that you'll be able to just run the script and it will enable Thunderbolt if you have USB 4. So let's say you've got an AMD system, it'll just treat it like Thunderbolt. It won't work right out of the box. It just doesn't. And yeah, I've done all the hard work for you guys, so I'll be releasing that on our GitHub in the next day or two. Let's drill down another level and just take a look at the VDev setup that I have. This is going to mirror exactly the same setup that I'm using for our current storage for our working setup. Everything here is not particularly interesting. You can see here we've got our RAID Z1 setup. Z1 is good for the uses of this for speed and capacity. This does have a backup job that runs and moves all of the files to another machine on the network, which has way more storage than this. Like I said, this is just working storage. I've got 3 datasets set up. Again, this mirrors the datasets that I have on that QNAP M.2 NAS. That QNAP M.2 NAS runs ZFS anyway, so, you know, you'll see with the performance what it looks like with the differences, and it's really interesting when it comes to performance differences. But as you can see, I haven't started populating any of the data on this server yet, but I will be migrating stuff over the weekend when I get some time. We've got 3 network shares, 1 for each of the data sets. This is all a pretty basic setup. The really interesting thing is there are products out there like HexOS, which tries to simplify all of this. But the reality is it all just works anyway. You don't need something to simplify it even more simply. Stay tuned though. On Printed Circuit Board, which is our second channel, I have a guide that I'm working on for a complete noob's guide to setting up TrueNAS from the ground up. So yeah, subscribe to the other channel. I'll put a link to that down below. One of the things that may confuse you with this setup is why do you have 2 network connections? Essentially, I have one 10 gigabit connection, which connects this to the rest of the network so other machines can see it, and that is purely for ingesting footage. It's not for the purposes of anything else other than ingesting footage. Now, while I'm filming in the studio, I will edit on the studio PC over 10 gigabit, but while I'm editing in my office on my editing PC, I'm using Thunderbolt. With this type of setup, you're only going to get 20 gigabit with Thunderbolt, which is fine. We don't need anything faster than that, and I'm happy to live with 20 gigabit for now. Maybe in 5 years' time, I'll make it go faster, but right now, yeah, that's how it is. Now, we're not running any containers or virtual machines or anything on here. We don't need anything. Other than that, the networking setup is quite basic. Again, I've got a single IP address for our physical network, and then I've got an IP address set up for the Thunderbolt network between this machine and my editing PC. And that's it. I want to show you guys what performance looks like because this may be interesting. All right, I've got some testing data to share with you guys based on some comparisons with both Thunderbolt and the existing storage solution that I'm using. So on the left here, this one right here, this is the Thunderbolt speed, which I'm getting to the QNAP M.2 SSD NAS. This thing is incredibly fast, and because it's all M.2 storage and it's NVMe storage, it is blazingly fast. Now, moving over to the right-hand side, this is over Thunderbolt with the new storage setup. You can see that overall it is slower, but this is also to do with the nature of USB 4 in Windows, as well as the limitations on SATA drives in general. However, the metric that is the most important for our use case is the sequential read, because what's happening is over Thunderbolt, I'm reading files as I'm editing. And if you compare the speed between the Thunderbolt connection on the new system as well as the Thunderbolt connection on the older NVMe M.2 system, the difference is, it's not negligible, but it won't make a difference to the workflow. I hope this makes sense. Now, you're probably wondering what this result here is. This is the network link speed over 10 gigabit with the new storage setup. Now, there is a bit of a discrepancy here with the write speed. I know you guys can see this, but again, this is to do with the nature of USB 4 and SATA. Whereas if we're accessing the same storage over Ethernet, there is a bit more buffering going on here, which gives us that bit of a bump in speed. This is good for one reason. The write speed is important because I'm writing data from the ingest PC to this storage at that speed anyway. Whereas the write speed on the NVMe NAS, that is the speed that you'd be getting over Thunderbolt, and I'm never writing to it over Thunderbolt. So I hope this is all making sense. Overall, the result is exactly what I expected, but to be honest, this is a bit of a mismatch comparison, essentially because the old storage setup here is all NVMe M.2 drives, and it is blazing fast, whereas this one here is 6 gigabit SATA. So it is slower, but I hope this gives you guys a little bit of an understanding as to the benefits of M.2 storage if you're trying to do something incredibly fast, but if you want something a bit more balanced for regular workflows. This speed here, guys, this one is more than adequate. However, if I was to use this exclusively over 10 gigabit networking, this result here is the best of both worlds. Now, I'm sure you're interested in knowing what the results are for 10 gigabit networking to that Thunderbolt NAS. Well, I haven't done that yet, so let's do this together. The result here from the NVMe M.2 SSD NAS is really good over 10 gig, but if you take a look at both the sequential reads and writes, the numbers here are pretty close. Where the new system loses out is on those random reads because of the limitation of SATA. While the gap in numbers is quite large in a real world usage scenario, it's not going to affect the workflow, and that's the most important thing. Bigger number better, but it's not always relevant. I hope all these results give you a little bit of an insight as to what network attached storage speeds look like and the nuances of, to be honest, how bad USB 4 implementation is in both Windows and how bad USB 4 is in general, but still usable. It's a mess of a standard right now. Hopefully they sort this stuff out in the future. Knowing what I know now, would I still do something like this and move all of our working storage to a setup like this? Well, simply the answer would still be yes. I know it's not as fast as the Thunderbolt NVMe M.2 NAS that I had before, but the reality is capacity. It's all about capacity. With the old setup, I had a usable storage pool of around about 12 terabytes, which just isn't enough. Now I have close to 25 terabytes, which if you do your math is more than double. So yeah, the answer again is still yes. Yes, it's not as fast as it was with the other setup, but capacity here is key, and it is all solid state as well. So we get the benefits of that. Being 2.5 inch SSDs, they don't get hot. They don't generate heat. They don't heat up a room that I'm in a lot of the time, and they don't make a sound because they're dead quiet. This new machine is dead silent. It might as well not even be on because you can't hear it. Whereas that Thunderbolt NAS, as I'm accessing it, the fans inside it spin up and start to make noise. It's almost like a laptop when it's under load. So it is something that I notice. And if I'm working and I'm recording voiceovers or I'm doing something that is really reliant on the sound in here, that introduces a problem of its own. So there's always trade-offs with everything when it comes to your gear for production. I would say that I made the right choice, but time will tell. I really don't know what the answer is right now. I think it's going to be just fine. Whether or not I use Thunderbolt though is now up for debate because the access speeds for just pure 10 gigabit may be enough. I don't know yet, but the bonus is I can link aggregate. This rack behind me has managed switches in it, and I can do lots of fancy networking things because, yeah, there's 10 gigabit networking right there in that rack. This is fun for me because I got to tinker and play with stuff and learn a little bit more about the inner workings of how Thunderbolt works in Linux. Because at the end of the day, underneath all of TrueNAS is just Debian Linux. As I already mentioned, I do have an in-depth TrueNAS tutorial coming very, very soon on our second channel printed circuit board, and that will help you with configuring it from the ground up. I also kind of want to integrate choosing hardware for it as well, or repurposing hardware you may have already got, like an old 5-year-old PC or just something like that. Let us know what you guys want to see if you want to learn some stuff from the ground up, because if you don't know, before all of this YouTube stuff, I was a data center guy who dealt with virtualization and storage. So yeah, I might be able to teach you guys some new stuff, maybe. I'm not just a Linux guy for the purposes of YouTube. I've been a Linux guy ever since I can remember, before it was cool. Once again, shout out to Samsung for sending all of the drives over for this and for some other projects. What if I told you that the NAS that you just saw me put together wasn't even close to the fastest NAS that I'm putting together at the moment? Stay tuned for this one, because it's going to be ridiculously fast.